Math 2 students, we are beginning the last week of our second grading period, our second 6 weeks. And this week is pretty much all about applications. So word problems, but I don't want you to panic when you hear the phrase word problems, because we're going to be graphing a lot of things on Desmos and just looking for specific features to answer the questions that we're looking for. So just, bear with me and keep an open mind about this, and you're going to be fine. So tomorrow is election day, so there's no school. So this lesson is Monday's lesson, and then there will be a lesson Wednesday and Thursday, and then you'll have a quiz on Friday. So this particular lesson is on what we call projectile motion, and what we mean by that is like if you were to throw a ball, or it goes up in the air to some level and then it comes back down. So it might look like one of these parabolas that you see here. This is what your PDF looks like that you'll be filling in. Mine's going to look a little bit different, but it will have the exact same problems that your PDF has. Remember that if you're watching this Edpuzzle video and you don't have this PDF open and working on it, they go together. So you want to do either the work on the PDF itself while you watch the Edpuzzle video, or you want to print this out, which you can do if you have a printer at home, and do the work on the video. Do the work while you watch the video, sorry. Or you can do the work on notebook paper if you'd rather just do your work on notebook paper. There are a couple different ways that you can share your work. Remember, you can take a picture of it, send it to yourself, and then paste it here. And the way you would do that is to use this Add Media button down. So when you go to the Add Media, you can either choose something from you can add it to your Google Drive and choose there, your computer. And let's see if I've got, here's a picture right here, a Bitmoji picture. So just drop your picture somewhere on here, make it bigger if it's kind of small and too small for me to see, and then just click Save or Submit over here. You probably should click Save just to make sure everything saves. The other option is to go over here to this comment button and then choose Video Comment and click somewhere on the page, and you're going to see me come up here. So click somewhere on the page, and then it's going to show you, and you just take your notes and do like this. You see how you can see my notes here? So you can just do like that, and then I can see all your notes, no big deal. Click Done, just like I did right there, and it's going to save that video over here on the edge of the page in the margin. And you can even choose a text box and type in over here. You can even do the microphone. There is a video of me holding up my notes to the right. There you go. And see, then I will see that right there. Make it big and make it, do it in red, do yellow background, whatever, just so I see it. So I make sure that I see that video, and then you'll get credit for doing the work. So 3 ways you can do it: notebook paper, print it out, or work directly on the PDF. And look, we've been doing this for a long time now. We've been doing this for about 8 weeks now. But just in case anybody is just now starting to work and starting to try to bring up some grades, I just want to make sure that you understand what the different ways are that you can turn in your work. All right, so I'm going to go back over here to my notes. Again, this is the same. Whoops, I did not mean to do that. This is the same set of notes. I just have it on my Smart Notes. Here's why. When I'm on the PDF and I'm trying to point to something like I'm doing right here, you can probably see this cursor with, let me do the cursor, maybe with a yellow circle around it or whatever. You can't see that on the PDF. So I have to constantly highlight stuff or circle stuff. And so it's just really better for me to do this over here on my Smart Notes. And so it's going to look exactly the same as yours. All right, let's get started now that I'm 4 minutes into this video. Okay, so here's the kind of thing we're going to see. So let's say this is somebody standing here. This is, of course, the y-axis and the x-axis. And typically what we use is, here's the y and the x-axis. This is quadrant 1. So we really only use positive values. I shouldn't have even drawn this all the way down here. We really only use positive values because we're talking about height and we're talking about time, and you don't do negative time, and there's no negative height. You're not digging a hole and throwing something into the hole. You're throwing it up in the air. So typically what you're going to see, you're going to see where maybe somebody kicked a ball, like they started at 0 at ground level, and they kicked a ball, and it goes like this, and then it comes back down. So you might see something like that. Or you might see where somebody's standing and they throw the ball, which means it's going to start at a little bit higher height, right? Because it's not going to start at the ground. That would be ground level down there. So it might start up here. So this might be a throw. And then the other thing that you might see is a drop. So like maybe you're way up here in a second story window, and you're dropping something from that window. So these are the typical types of problems we're going to see. The y-axis, get a different color here. The y-axis is usually the height, almost always. That's going to be the height that the ball was thrown, or the ball was kicked, or something was dropped. So that's actually going to be the y-intercept also. So that, you know, like the plus c part at the end of a quadratic formula equation, that's the height. And then the x-axis right here is almost always the time. So if I drop this ball from up here, that's the height that I dropped it at, which, you know, I don't know what that is. That might be 10 feet, might be 100 feet, whatever. So that's the height. And then this is the time. So like you might have seconds marked down here. So 1, 2, 3, 4, 5, 6 seconds. At 6 seconds, it was at the ground. Okay, so that's my x-intercept. At 5 seconds, it was whatever this height is right here. I don't know what it is, but this graph over here is what we're going to look at real numbers. But so this is kind of what we're looking at. And if we have the graph in front of us, it's really a lot easier to look at and to determine those different numbers that they're asking us for. Okay, so let's look at this graph right here. This says, how high is the ball when it leaves your hand? Really hard to tell on this one, but I'm going to estimate somewhere like right here. So really, this is the beginning of the graph. This yellow dot that I just drew right here, that's the beginning of the graph. All this stuff down here, that's not really part of this graph because the ball left my hand right here. I would say this is around like 12 feet. I think it's, well, maybe, no, it wouldn't be 12 feet, sorry, 12 inches. So that's how I'm going to answer that one. I'm going to say about 12 inches is about the height. What is the maximum height? Okay, so maximum height, I'm looking for the vertex y value. Because think about that. The y-axis is my height. Okay, so I need to look right here at the top at the maximum. And it looks like, okay, this is 194 right here. So I'm going to say about 200. I'm just guessing. About 200 inches. And when does the ball hit the ground? Okay, so this time I'm looking for the x-axis. I mean, sorry, not the x-axis, sorry, the x-intercept that is positive, because there's another x-intercept over here, but it's a negative number, and that's not where it hit the ground. It goes up and then comes back down, and it hits the ground at about, I'm going to say 7.2. That's what I would estimate. So this is kind of what we're going to be doing today. We are going to look at the equations too, but mainly we're going to be looking at graphs and just knowing like what we need to look for in which feature we need to look for, whether it's the vertex, the x-intercept, or whatever in the graph. There is a video that I want to show you that really kind of, this lady does a really good job of explaining this too, with the actual equation in it. And I'm going to actually not show it to you. I'm sorry. I'm going to link it in a note in a few minutes once we get through these 3 problems. And it's up to you. You can watch it if you want. I think that she does an excellent job. She has like a drawing, and she talks about dropping I think she talks about dropping a ball out of a window or something. So it's a really great video. She does a good job. All right, let's look at the next one on in that same section. Okay, so I have this parabola here. I've got a vertex up here. Looks like it's at about 6 seconds. So at 6 seconds, it was at the highest point, and it was at 10. So this point right here is at 6:10. This is the number of seconds. I think it's got to be seconds, because I mean, surely, you know, a ball doesn't stay in the air for minutes, so it's seconds. And then this right here is the maximum height. So that's, you know, that's the max. All right, so that's the maximum height. How high is the ball when it leaves your hand? Well, that is the Y-intercept, and that's how high the ball was when it left my hand. So about 4 inches, I guess, or no, let's say 4 feet this time, because maybe, you know, I'm like 5'4". Maybe some of you are 6 feet tall. 4 inches. I said it again. Sorry, 4 feet. What was the maximum height? Well, we've got it right here. It was 10 feet. And when does the ball hit the ground? That's over here. That is the x-intercept. When you're solving the equations, you'll get 2 different x-intercepts, but one of them is over here. Again, it's a negative number. So it's not going to be a negative number. It doesn't go negative feet when you throw it. It goes positive. So this would be the only one that would work, and this is at 14. So it hits at 14 seconds. All right, so that's that one. Let's look at the next one. Okay, how high is the ball when it leaves your hand? See, they have this, the negative part drawn on this one. This is really not part of what we're looking at. Even though they have that whole parabola drawn, it actually starts right here and goes this way. Okay, all right, and it does stop. It stops right here at the ground. So this is actually not part of it either. Parabola, you know, when you graph the equation, it goes forever in both directions. But if you're throwing a ball, it starts somewhere and it stops somewhere. Okay, so how high is the ball when it leaves your hand? It looks like it's at about, I don't know what this is in, you know, what it looks like, maybe, I don't know, inches, centimeters, who knows. We're just going to answer the number. So it is at 100, whatever that is, 100. Maximum height, that's going to be up here, and we're going to have to kind of estimate. That looks like about 200. And then when does the ball hit the ground? That's right here at this x-intercept, and I believe that was a 6. So at 6, let's say seconds. It's usually going to be seconds. So at this point, I'm going to talk about this, but I should be pausing the video and putting a note in there with the link to that other video if you want to watch it. Okay, we've already talked about a lot of this. The y-intercept is the height of the object when you throw it. How do you find it? We're just going to look at the graph. We're graphing these today. I'm going to talk a little bit about the equations and what the parts of them are, but we're graphing. So maximum height is the vertex. It is going to be just the y value. Okay. The x-intercept is the positive x-intercept, because there's another one. There's another one over here on this parabola, but that's negative. That's not going to work. So the x-intercept is when the ball hits the ground at, you know, ground level, which is a height of 0. Again, I'm not worried about how do we find this. We're not going to use formulas or anything. We're going to look at Desmos because Desmos is on our exam. Okay, and then so the x-intercept is the height. Is the seconds, or it's going to be seconds. Okay, so this is the time when it hits the ground, when it reaches that ground 0, as we would call it. Okay, so when you do see an equation, of course, our quadratic equations usually look like this: ax squared plus bx plus c. These projectile equations look a little bit different. You're going to pretty much always have negative 16 t squared. So that's the time right there. Negative 16, that is gravity. That is just the force of gravity on whatever it is you're throwing or dropping or kicking. Okay. And that is always going to be the same. If you see a 4.9 that is in meters, that is like a European measurement. So you might possibly see a negative 4. I think it's 4.9. I can't remember exactly. But the negative 16 is the force of gravity. The next part is going to be plus velocity times time. Okay, and so this is the velocity. This is how fast it's going. And I do want you to write this down. And let me grab a green pen. And the last thing is plus h. So the C, that is the original height, and it's the y-intercept. In other words, where does it cross that y-axis right there? Okay, so this is the h right here. The velocity is how fast is it going, right? Or how many seconds it takes for it to get where it's going. And then gravity is that's always going to be the same number. So I'm going to be working through some problems with you, but I'm also going to graph them on Desmos. We're going to take a look at one problem that's already graphed for us. This part I don't want you to worry about. So this is a graph of a rocket that gets shot into the air and then comes back down. So we see a few things. First of all, it starts at ground level. It starts at 0. It is in the air for 8 seconds because it comes back to the ground here, and it's 8 seconds. So 8. What is the greatest height? That's the vertex up here, and that would be the y value of the vertex. This is 250 right here. It looks like, I don't know what these are counting by, 10, 20, 30. They're counting by tens. So this looks like 260 to me. How high is the rocket after 1 second? Okay, so what you do is you go down to the 1 right here, and then you just follow that up. It's at about 100. Is the rocket going up or down at 100? It is still going up. Okay, after 6 seconds, where is it? So 6 is right here, so I just follow that up here, and that is at, that would be 190. And at that point, it's gone up, it's reached its turning point, and it's coming back down. So we're going to answer down here. Come on, just finish this on the next page. All right, this is the same graph. After 6 seconds, oh, I already had that one. We just did that one, right? Number 5, yeah. I just copied that one again by mistake. Do you think the rocket is traveling faster from 0 to 1 second or from 3 to 4 seconds? Well, let's see. From 0 to 1, it goes from 0 to 100. Okay, so this one goes from 0 to 100. And then from 3 to 4, here's 3, here's 4. I think that's 3 right there. So from 3 to 4, it goes from, what is that, 240 to 260. Well, gosh, that's 100 inches or whatever. I don't know, 100 feet. Oh, I guess it would be feet because this is a rocket. So this is 100 feet, and this is only 20 feet. So do you think it's traveling faster from 0 to 1 second or from 3 to 4 seconds? I would say 0 to 1. It travels 100 feet. But this is a steeper movement though. So you can form your own opinion about that. You can let me know what you think. Using the equation, find the exact value of the height of the rocket at 2 seconds. Okay, so what they mean by that is the equation is h equals negative 16 t squared I think, did they give us the equation? They did. Here's the equation right here. Plus 128t. Well, they've given you the time. They've given you the 2 seconds. So you would just plug in that number for t here. So h equals negative 16 times 2 squared plus 128 times 2. So just do the math. I didn't figure it out. You do the math and fill that part in. Okay, so I'm going to be doing some problems here for the rest of this video. But what I'm also going to be doing is pausing the video on Edpuzzle and giving you a separate problem to do. After we do one, then you'll try one. And this will be graded. It is multiple choice, but it will be graded and it will count as your classwork grade today. Okay, so this is our first problem, and this problem is on your paper. So we can go to Desmos, and we're going to go over to Desmos and graph this. The problem is when you graph one of these types of quadratic equations, here's what happens. Do you see how like skinny this thing is? Because the the A value is negative 16. So it makes it really skinny because it's that vertical stretch of 16. And so here's what you need to do. And this will work on all the rest of them. Go to this wrench thing over here, which is your settings, okay? Go to your x-axis. Change it, just like click right here and change these two numbers to just something smaller. Like you can even change this one to negative, or that's already got the negative in, negative 10, and then positive 10. And that will work. Okay, so see how much nicer that is to look at? I still have it a little bit, there we go. Okay, so what I'm going to do is I'm going to click on my vertex, my y-axis, or my y-intercept, sorry, and my x-intercepts. And I'm going to take a snippet of this using my snipping tool, and you could always do a screenshot. Now, here's the thing. I really don't need to look at the graph below this ground level right here, but the problem is that I've got this 50 written down here, so I'm going to go a little bit further down. I'm not sure what just happened to, oh, there's my picture right there. What I can also do is, I've got this custom white pen here on my snipping tool. The graph really starts right here at the 0, 80. This down here is really not part of the graph, because if you think about it, this is, what is it? It's a rocket, okay? And it gets launched from a hill above a lake. Okay, so it gets launched from this level right here, this 80, and then it goes up and then comes back down, and then this part down here is also not part of this graph. It starts at 80 and it ends at lake level or ground level right here. So that's really what I need that picture to look like. Okay, so let me see if it'll paste over here. I think it will. Let's see, Control V, there it is. And it even did my white part that I drew. Just need to make it a little bit smaller so we can look at it. Okay, so this is my rocket. Okay. And what are my questions that I'm being asked? What is the maximum height that it reached? Okay, so what I'm looking for maximum height is the vertex, but I'm only looking for the y value. Okay, so it reached a maximum height of 144. I'm assuming this is feet. Okay, how many seconds after it's launched will the rocket hit the lake? Okay, so I have time down here, and I think, let me go back to my graph because I'm not sure. These are counting by, okay, so it looks like it's at the 5. All right, I just want to make sure that I was right about that. Let me go back. Okay, so it's 5, I'm going to say 5 seconds is how long it took. So I'm looking for this x-intercept right here. Again, this x-intercept doesn't count. It won't work because it's a negative time, and we don't have negative time. It doesn't go negative 1 second. So it's going to be the x value of this ordered pair right here. So it was 5 seconds. What else can I look at? Well, they already told me that it was launched from a hill above the lake. Well, what height was the hill? Well, the height of the hill is right here. It was 80 feet or whatever. I'm assuming it's feet. So it was at 80. What was the height at, let's say, 4 seconds? If I wanted to know what was the height at 4 seconds, I would go to 4 seconds right here, and I would follow that line up to where it meets the graph, and it's about right there. These are counting by tens, I think. 10, 20, 30, 40, 50. Yep. So that would be 70. That's at the 70 mark on the y-axis. So at 5 seconds, or I'm sorry, at 4 seconds, it was at 70 feet, okay? And it was coming down. So there are a lot of different questions we can answer with these graphs. I think the next one, I actually want you to mark it out. Yep, I do. Number 9, we're not going to do that one. We're going to do number 10. And I went ahead and graphed this one on Desmos. Again, because I left this scale where it needed to be. How I made that so big. There we go. This is the graph that, let me move this down. There's ground level right there. So I only would need this part of this graph. So again, you know, you can change that X scale to smaller numbers. You could even go to 5. if you changed this to like a -5 to +5, let's see what happens. But you can always just kind of play around with that scale. That makes it a lot like fatter, but that's fine. It's still, you can still see it. So changing that X scale, all it does is it widens the X scale and it like spreads the numbers out more. So, you know, if you made it a little bit narrower, the 7 might be somewhere in here instead. So anyway, I already graphed this one, and it's right here, and I already actually, you know, marked the numbers. This part that I marked out in white, that's really not part of the graph. Okay, so Abigail has a bionic arm. She's crossing a bridge over a small gorge, so she's up higher than ground level. Decides to toss a coin into the stream below for luck. It says she has a bionic arm because bionic arm, of course, can throw a lot farther and a lot higher. So this is the equation up here at the top. And again, you know, you've got that -16 for gravity, where X measures the time in seconds, Y measures the height in feet. So this is in feet. Find the greatest height the coin reaches. Okay, greatest height the coin reaches is the Y value of the vertex, 256. Find the time that the coin hits the water. The coin hits the water at 7 seconds. And that's it. That's all you have to do. All right, let's look at another one. I also wanted to show you something. Normally I tell students if you put any other letters in here besides X for the variable, it's not going to work, but T will also work because obviously this is a projectile function, and so the T will also work. So this one's still really wide, so I'm going to go back in here and change my X-axis again. I'm going to change it to like 30 and see what happens. -30 and +30. That's a little bit narrow for my taste, so I'm going to go in and, oh, they changed it. They changed it to 20. That might work if I bring it in some. Okay, yeah, I think that'll work. Okay, so I got a snippet of that graph and it wouldn't paste for a second. So let me make it manageable for the size. All right, so again, what is not part of this? This part right here is not part of this graph. Oh, sorry, that the arrow thing showed up in the picture. That's not part of this graph because it starts out, she's diving from a diving board. Oh, change this to 40 because that says 40 right there. This should say 40. She's starting out on a diving board that's 40 feet high. So the part down here, this is like the steps up to the diving board. This is not part of the problem. She's starting on a diving board. She jumps up and then comes back down, and this is where she hits the water. Okay. Let's see, how many seconds, after how many seconds does Janet enter the water? The height above water would equal 0. Okay, so right here, we get a different color. It would be right here, 2.5 seconds. And then what's the other question? What's the greatest height that she reaches? Not that number, but this one. She reaches 49 feet. So she jumps 9 feet from here up to her highest point and then back down. Dives don't usually look like that. They're usually more like this. But anyway, all right. It's just a hypothetical. All right, so that's the end of this lesson. You had, I think, 6 problems that you had to do along the way, and that will be your grade. Come to the live meeting today, and I can answer any questions that you might have about any of the problems that are on here. And you'll, of course, get your extra credit point for coming to the live meeting.